Okay, today I want to begin by reviewing the function syntax, and after that we'll go over some examples. So here's what I mean by syntax. We have an algebraic equation here, and each piece has a different significance. So for example, let's begin with the function f. The capital F along with the parentheses, that is the function, that is your machine. Think about it as the converter. X, whatever is inside of the parentheses, that's going to be your input. Here's what you can put inside your machine, and you can find these in your x-axis. Finally, you have the output, or whatever f of x equals, that's going to be your value. You can find these in your y-axis. When you put it all together, and when somebody wants to read what this says, here's how you read it. F of x is equal to a. I don't think I can stress this enough, the importance of knowing how to read this. This is not f multiplied by x. This is function notation. Whenever you see this, please be familiar that this is read as f of x equal to a. Let's look at some examples where you're going to have to evaluate functions using the graph of a function. So here we have this graph, and we have to use it in order to answer questions A through D. I've included all the labels. For example, here we have the y-axis, that's the vertical. And then here we have the x-axis, this is the horizontal. And the x-axis, that's the inputs. The y-axis, those are the outputs. I've outlined the x-axis and the y-axis in green, just so it's a little bit more clear. Now this graph here, this one is called f of x. This is the name of the graph. The blue graph is f of x. Let's begin by addressing part A, where we want to find f of 9. So in order to evaluate f of 9, again, we have to be familiar with the syntax. Whatever is inside the machine, whatever's inside this machine, that's going to be my input. If we take a look back, here we can see that 9 is the input right here. In the inputs, we can find them on our x-axis. So we got to look for 9 here. So if we take a look, 9 is right there. Now we have to find the value of the function at 9. And in order to do that, well, we have to go up towards the function. And we get this point right here. So let's mark it. And we see that the y value is going to correspond to 3. So f of 9 is going to be 3. Let's evaluate f of 5 now. We're going to do the same thing. We're going to look at the input. This time we have 5. So we're going to look at our x-axis because those are the inputs, and we're going to look for positive 5. Positive 5 is right here. And we want to look at the value for f of x, so we have to go towards the function. And we see that we get this dot right here, which is already labeled in blue, but I'm going to outline it in green. And we can see that the y value that corresponds to my x value, that's going to be 3 as well. So f of 5 is also 3. Let's do this again with f of 2. The input is 2, so let's look at the x-axis because that's the inputs. Let's look for positive 2. Positive 2 is right here. We want to get the y value that corresponds to f of 2. So we have to go towards the function. And we see that this point is already outlined in green. But again, we're going to highlight it in... Sorry, it was outlined in blue. We're going to highlight it in green. Re-highlight it. So here, f of 2, that's going to be... So f of 2, that's going to be 1. So we get that f of 2 is 1. This last part's a little bit different because this time we're not given the input. Instead, we're given the output. So we're given that the output is 6. So when f of x equals 6, then x equals, we're trying to find the input. So we're going to do the reverse order. Since we're given the output, we're going to begin here at y. And we have to look for 6. So 6 is right here. So now we're going to go towards our function f, and we see that we hit it at this blue point right here. So let's re-highlight it in green. And now we want the x value that corresponds to this y value. So we're going to go down and we see that we get 16. So when f of x equals 6, then x is equal to 16. Let's practice this idea with one more example. So here we have to again use the graph of the function in order to evaluate each expression here on the right. Let's begin by addressing part A. Here we want to evaluate f of 3, and we are being given the input. So we're going to have to make use of the x-axis, and we got to look for that 3. So we look and we see that positive 3 is right here, and now we have to go towards our function in order to get the y value. So here we see that we get this blue point. Let's re-highlight it in green. And now we see that the y value that corresponds to this x value, that one's going to be 3. So f of 3 is equal to 3. For part B, we're going to evaluate f of 0. So we have the input of 0. And whenever you're looking at the x-axis, you can think of 0 as being the origin, or being in the origin. So here 0 is right there. So let's I'm gonna highlight this in green. So here we have 0, 0, but we're trying to evaluate f of 0. So we gotta go towards our function, the blue one, and we see that we hit it right here at this blue point, which I'm gonna re-highlight in green. And we see that the y value that corresponds to this value of 0, that's going to be 6. So f of 0 is equal to 6. Depending on how much you remember from last year, you might make the connection that this is your y-intercept. So this is the y-intercept of this graph here. Let's move on to part C. So this time we're given the output. F of x equals 4. Then x is going to be equal to, that's what we're trying to figure out. So here we're going to make use of the outputs this time. And here I'm getting an output of 4, so let's look at the y-axis and let's search for 4, which is right here. And now I'm going to go towards my blue graph to get the x value. So here we see that we hit the function f of x right here. So let's make a little dot here. And now we see that the x value is 2. So here x is going to equal 2. Okay, and actually let me make it in yellow. That way you can see the difference. For part D, we're also looking for the output, or sorry, we're looking for the input because we're given the value. So my output is 5, so I'm going to go to my y-axis and search for 5, which is right there. I'm going to go towards the function f of x, and it gets hit right here at that point. So now we're trying to look for the x value that corresponds to this y value, and that one we can see that it's going to be 1. So if f of x equals 5, then x equals 1. For the final part here, we're trying to evaluate an input again. So we're trying to look for f of 12. So this is an input. So let's look for our, well, let's use the x-axis and let's search for 12. 12 is right here. And now notice that this time I'm not going up because f of x doesn't exist above here. It actually exists below. So here I'm going to have to go down. And I see that the y value that corresponds to this x value, and here let me highlight the dot in green. That one is going to be -4. So f of 12 is -4. Okay. Try out the examples, and then if there's another video, take a look at it, and you should be good.